So, yo, what's up, guys? Welcome to day number 8. Day number 8. Yeah, basically, anyway. Today we're solving remove the node from the end of a linked list. So, we previously done some practice in day 6 and 7. It was easy. Not really, but this is the medium version, and we are just gonna see how well can we do. So the question reads: you are given the beginning of a linked list head and an integer n. Remove the nth node from the end of the list and return the beginning of the list. So n is 2. So the nth node would be 1, 2, 3, gone. 1 from 5, so the last one's da. So 2, so 1, 2, remove 1. So just thinking about this problem, the hardest part, because it would be easy if it was the start of the list, but it's the end of the list. So yeah, I guess you have to get to the end of the list somehow. Okay, so what can we do? First thing I'd say is probably use 2 pointers. It's usually the pattern for this one. So we can use 2 pointers. So what does that look like? Whenever we're doing anything like this, to be fair, you need to set a dummy node. So in this case, it would literally look like this. 0 for the value, and just give it head, because that's going to be beginning. So first things first, with setting pointers, you need to understand why we set them. So we are going to set 2, left and right. You could just call it L and R because we are super lazy on that. So L will identify the node to delete. So L, so left. So that's its purpose. Yeah. Node to delete. So what is that going to look like? We use a dummy node. Why do we use it? Because we're going to do something like this. Let's call it L. New, not new, dummy. And then we're going to use a right pointer for what? You probably guessed it if you've been watching my videos. If not, you should be watching the videos. But the right one will be used to get to the end of the linked list, which is going to be really important because we're going from, we need to know the end to work. So how is that going to be? To get to the end of the linked list. So what's that going to look like? It will look like this. So list node R is going to be considered head because we're going to start at the beginning. Now, decisions. So we need to get to the end of the list somehow. How do we do this? We iterate through using a while loop. So the conditions that we're gonna do are gonna be, okay, let me just do this. Iterations to get to the end of the, just call it LL because that is very simple. Condition is n0 and right equal to null. So that's what we're gonna do. And right is not equal to null. So what do we do during this condition? We're gonna say, gonna increment the right pointer. Naming convention is terrible. Increment right pointer is r.next, so we're moving forwards, and then we're gonna say n minus minus. So just to decrement it that way. Now, do not put the while loop inside the other while loop because you're gonna get crazy time complexity, and yeah, but do it separate because they are two separate conditions. One to get to the end, one to identify the node. Then we're going to perform the operations once all the pointers are in place, and then we can return the header of the linked list and get the answer correct. So we're planning to do. So we're gonna say whilst r is not equal to null. I'm sure we could simplify it. So just tell me, guys, if you think you're smarter than me, yeah, just tell me, you know. Probably are, to be fair, but so whilst r is not null, we're gonna say that L is going to be equal L dot next to increment that. R is equal R dot next. Increment that. Once we've got the pointers in place, we can say L dot next equals L dot next dot next. So this is how you delete in little L by updating the pointers, which is why you can, which is an O of 1 time complexity operation. Very important you know that, because that is one of the advantages of a linked list. Right, so once we've deleted the node that we've selected and all the pointers are in place, what do? Super simple. We return the dummy node. Check how we do. Oh, so terrible. 29. Oh, I always forget to do this. It's fine. Yes. Now, the worst thing that ever happens is when you pass the test case in a run, but you don't pass in the submit. But we passed it in the submit. Okay, guys, that's day 8. See you guys on day 9.